Good everyone, my name is Graphics. Today we are told to Laplace e to the power of minus t cos 2t. Now, whenever you see e to the power of anything multiplying any variable, right? Multiplying any function, what you should be doing is that we'll call it the first shifting theorem. That is what we'll be applying, right? So when you Laplace cos at, right, you'll be having s all over s squared plus a squared, right? But in this case here now, we are having cos 2t, meaning that what? Our a is 2. So whenever I see a, I'm going to put what? 2. So I'll now be saying that my cos 2t will now be giving me x all over s squared plus 2 squared. Is that okay? So this is what I'm going to write out first. Now, if you look at what is in front of the cos 2t, what is behind the cos 2t? It is what? E to the power of what? Minus t. And we have a relationship of e raised to power anything, raised to power negative of anything, which is when you have, recall, when you have e to the power of minus at, it is going to give us 1 all over s plus a, right? Now, in this case, our a is now 1, because it's only when a is 1 that you can have t left. So if our a is 1, so it means that my e raised to power what? Minus t will give us what? 1 all over s plus. Now what you need here is the denominator. What is the denominator? The denominator here is what? S plus 1. So you now go back to our question here, where we have s all over s squared plus what? 2 squared. So anywhere you see x, you are going to put the denominator of e raised to power what? Minus t, which is what? S plus 1. So anywhere I see s, I'll put s plus 1. So we'll now say that what? S plus 1 all over s plus 1 all square plus 2 square. So therefore, the Laplace of e to the power of minus t cos 2t will give us what? S plus 1 all over s plus 1 all square plus 2 square. So that will be our answer for question 1. Now, example 2. We are told to Laplace e to the power of minus 3t into bracket cos, into bracket 2 cos 5t minus 3 sine 5t, or close the bracket, right? Now, what you do first of all, you try as much as you can to simplify this. You expand it, right? So if I expand it, first of all, I am going to use e to the power of what? Minus 3t to open the bracket, right? So if I open the bracket with e minus 3t, so if you say e raised to power minus 3t multiplied by what? 2 cos 5t. Now we know the constant will always be in front of the variables or the functions. So instead of me write, I'll now write 2e to the power of minus 3t cos 5t. I've brought the 2 out. Now, if I use the same e to the power of minus 3t times 3 sine 5t, the variable will come in, the constant will come in front of the function, so we'll now be having 3 e raised to power minus 3t sine 5t. Now this is what we're having. Now if I now open the bracket with the Laplace, right? So I will now the constant will come in front of the Laplace. So the Laplace of e minus 3e, the Laplace of 2e minus 3t cos 5t will be written this way, minus the Laplace of 3e minus 3t, e to the power of minus 3t sine 5t will give us what? This is how we are going to write it, right? Now we have gotten back to what we call first shifting theorem. Whenever you have the e and any other variable, any other function together like this, you apply what is called, we call that the first shifting theorem. Now if you look at this very well, I'll bring out my 2, right? Since the constant is behind the Laplace, and I'll open a bracket this way. I'm focusing more on what is in front of the e to the power of minus 3t, and what is that? Cos 5t, right? Now recall, we know when you have cos at, it will give us s all over s squared plus a squared. But now our a is now represented by what? By 5. So my cos 5t now, wherever I see a, I'll put 5, will now be what? S all over s squared plus what? 5 squared. I'm going to write it here, right? Now we're having e to the power of minus 3t. Recall, whenever you have e to the power of minus 8t, we'll be having 1 all over what? S plus a. Now in this case here now, our a is 3. So we'll say that my e raised to the power of minus 3t. Anywhere I see a, I'll put 3. So we're having 1 all over what? S plus 3. So what I need here is the denominator. The denominator is s plus 3. So I'll now come here. Wherever I see x in this function here, I'm going to put what? S plus 3. So I'll now have 2 into brackets, s plus 3 all over x plus 3 all square, because the s here has square, so it will put all square here, plus what? Plus 5 square. So this is what we have for the first one here. Minus, I'll bring out the 3 again. I'll bring out 3 from here because it's behind the Laplace, is the constant. And I will now focus on e to the power of minus 3t sine 5t, while Laplacing that. Now we know very well what you focus on here now will be what is in front of the e to the power of minus 3t. What is in front of the e? And that is sine 5t. And we know very well that, recall that sine 8t will give us a all over s squared plus a squared, right? And when I now represent my a with 5, so we're having sine 5t. Wherever I see a, I am going to put what? 5. So we're having 5 all over s squared plus 5 squared. I'm going to write it here, right? Now I've written that there. That is not all. I will now focus on the e to the power of minus 3t. We know that e to the power of minus 8t is what? 1 all over what? S plus a. And in this case, my a is 3. So when I put my a to be 3 here, so I will now say that e to the power of what? Minus 3t will now give us 1 all over what? S plus 3. So whenever I see s, I'll focus on what I need here is denominator. So whenever I see s, I'm going to put the denominator of this, which is what? S plus 3. So I will now write that 3 into bracket 5 all over, now this is s, but this s here has square, so I'll be putting s plus 3 all square. So I represented my s by what? S plus 3 plus what? Plus 5 square. So this is what we have here. Now if I expand, I can say that the 2 will multiply s plus 3, we'll be having 2s plus 6, because 2 times s is 2x and 2 times 3 is 6, all over s plus 3 all square plus 5 square, minus 3 times 5 is what? 15. So we're having 15 all over s plus 3 all square plus 5 square. If I like, I'll put my 5 square to be what? 25. Is that taken? So that is the answer to that question. So we say that the Laplace of e to the power of minus 3t into bracket 2 cos 5t minus 3 sine 5t will give us 2s plus 6 all over s plus 3 all square plus 5 square minus 15 all over s plus 3 all square plus 5 square. So that is our answer. Now we move further. Example 3. We are told to Laplace e to the power of minus t cos square t. So we are told to Laplace this. Now, if you have to Laplace this, like I said earlier, you are going to focus on what? Cos square t. Now, since you don't have any relationship in the form of what? Cos square t, that means you have to break cos square t down by applying your what? Your trigonometry identity. Now, for where you can see cos square t is where you break down this double angle, which is called what? Cos 2t, right? In terms of cos 2t will give us 2 cos square t minus 1, right? In your double angle. If you click up to this video at the top right corner of the screen, you will be able to understand how cos 2t is giving us 2 cos square t minus 1, right? Now, if what I need here is cos square t, so if I make cos square t the formula, if I take 1 to the other side, I'll be having cos 2t plus 1 is equals to what? 2 cos square t, right? Now, I want cos square t to stay alone, so if I divide both sides by 2, I'll be having cos 2t plus 1 all over 2 is equals to what? Cos square t, right? This is what we have it. So if I want to write it again, since they have a common denominator, my cos 2t over 2 plus 1 all over 2 is equals to what? Cos square t, right? This is how you can write it since they have a common denominator. So this is what we are going to Laplace now, right? This is what we are going to what? We are going to Laplace. So if I write this out, so another way of writing this function up here is by writing the Laplace of e to the power of minus t, right, times cos 2t all over 2 plus 1 all over 2. You put this into bracket this way. Is that taken? And you close up the bracket. This is another way of writing it now. So we'll now open the bracket. So the Laplace of, if you use raised power minus t times cos 2t over 2, we're having 1 all over 2 e minus t cos 2t. Now I brought the 1 over 2 because the constant, right, in front of the e, right? The constant will always come in front, or I will say will come behind. Plus, now if you open the bracket, we'll be having 1 all over 2 of what? Laplace e to the power of what? Minus t, right? So this is what we are having here. Is that okay? Now the e raised power minus t, in front of it we are having 1. Now let's start. So if I now open the bracket further, right, I will now be having this. I'll focus on the cos 2t first. With what we did earlier in our previous video, we know that we'll bring out my 1 over 2 out first. You open the bracket. When you Laplace cos 2t, if you watch the previous example, cos 2t is like saying cos at, right? And my cos at is written as s all over what? X squared plus what? Plus a squared. And when it's now 2, it will now give us, if it's 2, our a is 2, anywhere you see a, you put 2. So we're having s squared, s all over s squared plus what? 2 squared. This is what we have here. This is what I'm going to write here first. You do it somewhere in your book, in your booklet. So s all over what? S squared plus what? 2 squared. Now, if you now Laplace e to the power of minus t, right, from the relationship that says that e to the power of minus at will give us what? 1 all over what? S plus a. Now, our a here is now 1 because 1 times 2 gives us t. So if you now put 1 in front of the t, right, anywhere you see a, you put what? 1. So we're having 1 all over what? S plus what? S plus 1. So we'll be focusing on the denominator here, which is s plus 1. So if you come back here, anywhere you see s, you put what? S plus 1. So instead of me writing s all over s squared plus 2 squared, I'm writing s plus 1 all over what? S plus 1 all square all over 2 square. So this is what we are having for the first one here. Plus, now if you Laplace e to the power of what? Minus what? Minus t, right? When you Laplace it, what you be having? We are going to be having, you first of all bring out the 1 all over 2 and you open the bracket, right? So if you now Laplace e to the power of what? Minus t, right? You are going to be having 1 all over what? S plus 1, just like we did earlier. So when I open the bracket, I'll be having 1 all over 2 into bracket s plus 1 all over s square plus s plus 1 all square plus 2 square plus 1 all over 2 into bracket what? 1 all over s plus 1. You can leave it that way. So this will be my answer, right? So this is what we call the first shifting theorem. Whenever you are seeing the e multiplying any other function, right? So in our next video, we'll be looking at where t is multiplying any other function. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.